A sin omega t plus B cos omega t into dt. Is that okay to you, sir? So A, if you integrate sin omega t minus cos omega t divided by omega plus B sin omega t by omega. This is the expression for Q. So the values of I and Q and di by dt we have to substitute in equation 1. Okay, sir? Substituting di by dt and Q in equation 1. What do you get? E naught sin omega t is equal to R in the place of I, A sin omega t plus B cos omega t plus L di by dt A omega cos omega t minus B omega sin omega t plus 1 by C minus of A omega cos omega t plus B by omega sin omega t. What I have done is I have substituted the values of I, di by dt and Q in equation 1, and therefore I have ended up with equation number 3, sir. As you can see there are two unknowns, A and B constants, which we have to determine applying boundary condition. What is that we do? We say at t is equal to 0, sin omega t is 0, cos omega t will be 1. I suppose there is no problem in understanding this. We are going to substitute these values in equation 3. So, equation 3 becomes sin omega t 0, 0 is equal to RB. Omega t is 0, cos omega t is 1, therefore it will become RB plus L A omega minus A by C omega. Is that clear to you, sir? Is that clear to you, sir? So from this, I make it as RB plus A can be taken out, becomes L omega minus 1 by C omega. Therefore, I write B is equal to minus A by R into L omega minus 1 by C omega. I will call this as equation number 4, sir. Is that clear to you? Now, shall I rub this off? condition has to be substituted, so that we get one more expression for constants A and B. So the condition will be at t is equal to t by 4. Sin omega t will be 1. Cos omega t will be 0. So t by 4 will be right here. Okay. Therefore, this will become E naught is equal to RA minus L d omega plus B by C omega. So this will become RA minus B. Is that okay to you? L omega minus 1 by C omega. Now from equation 4, I can substitute for B. Therefore, I get RA minus or minus will become plus. Okay. A by R into L omega minus 1 by C omega the whole square. Is that okay to you, sir? From this, if I take A common outside, I get R 1 plus R L omega minus 1 by C omega the whole square. Is that okay to you? Now from here, I can get the value of A. How do I get that? I will modify it like this. R squared plus L omega minus 1 by C omega the whole square by R. Okay. Here I have a E naught. Right? If I can rub this off, I will definitely get an expression for A, I believe. Right? Therefore, my A will be E naught R upon R square plus L omega minus 1 by C omega the whole square. If I can give a number for this, that will be fine. Am I right, sir? This value of A can be substituted in 4 to get B. B will become equal to E naught L omega minus 1 by C omega upon R square plus L omega minus 1 by C omega the whole square. So we have got expression for A and B, sir, in the form of equations. Of course, B has a minus sign, therefore a minus sign will come here. These values of A and B can be substituted in the general solution which we have assumed. So what happens? I will rub this off. Therefore, cos omega t. Minus sign is there. Therefore, this will be minus E naught L omega 1 by C omega upon R square plus L omega minus 1 by C omega the whole square into cos omega t. Now we need to modify a little bit in this form. E naught upon under root of R square plus L omega minus 1 by C omega square. Bracket open. This will be R sin omega t upon under root of R square plus L omega minus 1 by C omega square. Okay? Minus L omega 1 by C omega cos omega t upon under root of R square plus L omega minus 1 by C omega square. Okay, sir. I will rub this part. Put R square plus L omega minus 1 by C omega the whole square is equal to cos phi. Okay. L omega minus 1 by C omega upon under root of R square plus L omega minus 1 by C omega the whole square is equal to sin phi. If that be the case, this equation will take the form in line up. I will be equal to E naught upon under root of R square plus L omega minus 1 by C omega the whole square into sin omega t cos phi minus cos omega t sin phi. Therefore, I will rub this so that the equation for I will become I naught sin omega t minus phi. This is equation 7 for me, sir. Okay. And what is that I naught? Where? I naught is E naught upon under root of R square plus L omega minus 1 by C omega square. Okay. Now, if I draw a impedance triangle, okay, I call it as impedance triangle. This will be Z, okay. This will be R and this will be L omega minus 1 by C omega. So this factor under root of R square plus L omega minus 1 by C omega square, I call it as impedance. Impedance here means the effective opposition offered to the flow of alternating current by a circuit comprising of R, L and C. I repeat, impedance Z is nothing but the effective opposition offered to the flow of alternating current by a circuit comprising of L, R, L and C. Now this, if I take it as phi, from here, from this I can write tan phi, opposite side, by adjacent side. This is phase angle difference phi. So you can say, shall I have this off? This part. So here from this expression it is obvious that in a LCR circuit current lags the applied EMF by a phase angle phi. Whether it will always lag, it all depends on the values of L omega and 1 by C omega. Therefore I say if L omega is greater than 1 by C omega. See, if L omega is greater than 1 by C omega, phi is positive, therefore current lags. Okay? If L omega is less than 1 by C omega, phi is negative, current minus or minus will become plus, leads the applied EMF. Okay? If L omega is equal to 1 by C omega, phi is 0, then current is in phase. So in an LCR circuit, when does the current lead? When does the current lag? When the current is in phase. I have given the condition. I have also told you Z is equal to this, we call it as impedance, and this phi as phase angle and cos phi as power factor. This is known as power factor. This can also be written as cos phi as equal to R upon Z. Ratio of resistance to impedance, we also call it as power factor. So with this, we'll stop here. We have discussed a few topics in the next part of unit 4, namely alternating current and its related circuits. Today we have seen what an alternating current is, alternating EMF is, what is mean value, what is root mean square value, and the related equations of an LCR circuit. We'll stop here, continue in the next class from where we have stopped. Please go through the videos carefully and make necessary notes. All the best. Goodbye. We will meet again in the next class. Until then, bye-bye.